Hello my lovely students, you're welcome to a new lesson. Today, I shall be teaching you quadratic equations. From definition, a quadratic equation is an equation in which 2 is the highest power of the unknowns. Also, a quadratic equation is an equation of degree 2. That means that the highest exponent of the equation is 2. The general form of a quadratic equation is ax squared plus bx plus c equal to 0. Let's learn more about quadratic equations. Let's learn how to make quadratic expressions perfect squares. Quadratic expressions of the form x plus a all squared and x minus a all squared are known as perfect squares. That means that expanding the form x plus a all squared, we have x plus a multiplying itself, which will amount to x squared plus 2ax plus a squared. Also, expanding the form x minus a all squared will give us x minus a multiplying itself x minus a, which will expand as x squared minus 2ax plus a squared. Let's see an example on making quadratic expressions perfect squares. Example 1. Question A. What must be added to x squared plus 6x to make the expression a perfect square? Question B. Factorize the result. Looking at the solution to question 1a, we have two methods in making the expression a perfect square. Method 1. Let the number to be added to make the expression x squared plus 6x a perfect square, let the number be k. That means x squared plus 6x plus k is equal to x plus a all squared, which is a perfect square. Expanding x plus a all squared, we are going to have the equation as x squared plus 6x plus k is equal to x squared plus 2ax plus a squared. Now, how do we solve this equation? Let's see. Comparing or equating the terms of x, we have 6x on the left hand side of the equation is equal to 2ax on the right hand side of the equation. Solving for a, we have a is equal to 3. Also, comparing or equating the constant terms, we have k on the left hand side of the equation is equal to a squared on the right hand side of the equation. Don't forget, a is 3, so k is equal to a squared, which is 3 squared. K is equal to 9. That means that 9 must be added to the expression to make it a perfect square. Looking at the second method of how to solve question 1a, once again, let the number to be added be k. That means x squared plus 6x plus k is a perfect square. Now here is a formula for k. The formula for k is equal to the square of half of the coefficient of x. That means that k is equal to, in bracket, half times the coefficient of x all squared. Please take note of this formula. So what is the value of the number to be added, which is k? K is equal to half times the coefficient of x, which is 6, half times 6 all squared. Half of 6 is 3, so 3 all squared will give you k equal to 9. K equal to 9 must be added. Take note that this answer k equal to 9 agrees with the answer we got from the first method. Now let's see the solution to question 1b. Let's factorize the result. The perfect square expression is x squared plus 6x plus 9. Factorizing, we have x squared plus 6x plus 3 squared. Don't forget, 9 is the same thing as 3 squared. When we factorize this perfect square expression, we are going to have x plus 3 and another x plus 3, because x is a square, 3 is also a square. That gives us the result x plus 3 all squared from factorizing. I hope this solution is clear to you. Let's see a second example on making quadratic expressions perfect squares. Question 2a. What must be added to n squared minus 7n to make the expression a perfect square? Question 2b. Factorize the result. Now, can you tell the answer to this question from your knowledge of example 1? Let's see if you can. For the solution to question 2a, we are going to solve using two methods once again. For method 1, let the number to be added be k. That means n squared minus 7n plus k is equal to n minus a all squared. Here we are using n minus a all squared because the question says n squared minus 7n. Expanding this result, we have n squared minus 7n plus k is equal to n squared minus 2an plus a squared. Now comparing the terms of n, we have a is equal to 7 over 2 from calculation. While squaring the value of a, we have k is equal to a squared, which is equal to 49 over 4. That means 49 over 4 must be added to n squared minus 7n to make it a perfect square. Looking at the second method we can apply, let the number to be added once again be k. Now there's a formula for k. The formula is k is equal to the square of half of the coefficient of n. That means k is equal to, in brackets, half times the coefficient of n all squared. That gives us k is equal to half times the coefficient of n is minus 7. So half times minus 7 all squared will give us minus 7 over 2 all squared. K remains 49 divided by 4, which must be added to make the expression a perfect square. Take note, this answer agrees with what we got in the first method. Looking at the solution for question 2b, factorizing the result, we have n squared minus 7n plus 49 divided by 4. Let's factorize. 49 divided by 4 is the same thing as minus 7 over 2 squared. So factorizing, we have n minus 7 over 2 into n minus 7 over 2, because n is a square. Also, minus 7 over 2 is a square. Here we have minus 7 over 2 squared because the coefficient of n is minus 7. Factorizing completely, we have the answer as n minus 7 over 2 all squared. I hope you got these answers correct. Moving on, let's see the methods of solving quadratic equations. We have 4 methods of solving quadratic equations. Number 1, we have factorization. Number 2, we have completing the square. Number 3, we have quadratic formula. While number 4, we have graph method. The solutions of a quadratic equation are called the roots of the equation. Let's solve a question involving the method of solving quadratic equations. Example 3. Solve x squared plus 2x minus 3 equal to 0 using the 4 methods of solving quadratic equations. Let's see the solution to question 3a using factorization method. The question is x squared plus 2x minus 3 is equal to 0. How do we factorize? We multiply the x squared term and the constant term. That means we multiply x squared and minus 3 to give us a product of minus 3x squared. Next, we look for 2 factors of the product minus 3x squared, which we add up to the middle term, which is plus 2x. The 2 factors are plus 3x and minus x. Because if you multiply these 2 factors, you get minus 3x squared. While if you add up the 2 factors, you get the middle term, which is plus 2x. Next, we replace the middle term plus 2x with these 2 factors. That means the question becomes x squared plus 3x minus 3 is equal to 0. Do you know how we can factorize this equation the way it is? Let's see if you know. Factorizing by grouping in pairs. You're going to have the first 2 terms, which has a highest common factor of x. Factorizing, you have x into x plus 3. And also factorizing the second 2 terms, which has a highest common factor of minus 1. Factorizing, you have minus 1 into x plus 3. Now the x plus 3 is appearing twice. You pick one, while your 2 highest common factors, x and minus 1, you put them in the second bracket, being equal to 0. Solving these 2 brackets separately, being equal to 0, we have x is equal to minus 3 or x is equal to 1. That gives us a final answer of x is equal to minus 3 or 1. I hope this idea is clear to you. Moving on, let's see how we can solve this quadratic equation using completing the square method. The question remains x squared plus 2x minus 3 equal to 0. Now what we do, we move the constant term minus 3 to the right hand side. That gives us x squared plus 2x is equal to 3. Now let's make the left hand side of the equation a perfect square. How do we do this? Of course, we add the square of half of the coefficient of x to both sides. That means we are adding half times the coefficient of x all squared to both sides. We have to add half times 2, which is the coefficient of x all squared. That means we are adding 1 squared to both sides. That gives us x squared plus 2x plus 1 squared is equal to 3 plus 1 squared. Now do you know what we must do from this step? Let's solve on. Factorizing the left hand side of the equation, which is now a perfect squared, we are going to have x plus 1 into x plus 1 because x is a squared and 1 is a squared. On the right of the equal to, we have 3 plus 1. That gives us x plus 1 all squared is equal to 4. Now solving on by making x the subject of the equation, we are going to have two answers again as the root of the quadratic equation, which is x is equal to 1 or minus 3. Take note, this answer agrees with what we got from factorization method because the question is the same. Moving on, let's see how we can solve this quadratic equation using the quadratic formula. Now the general form of a quadratic equation remains ax squared plus bx plus c is equal to 0. Now what is the quadratic formula? The formula is x is equal to minus b plus minus root b squared minus 4ac divided by 2a. Please take note of this formula. In the formula, a is the coefficient of x squared, b is the coefficient of x, while c is the constant term. Now what we are going to do next is to identify the numbers which are a, b and c in the question and substitute into our quadratic formula. Let's see how it works. From the question, a is the coefficient of x squared, which is 1, b is the coefficient of x, which is 2, while c is the constant term, which is minus 3. Now, substituting these values into your quadratic formula and solving, this is what you should get. Our final answer from quadratic formula should be x is equal to 1 or x is equal to minus 3. I hope this method using quadratic formula is clear to you. Lastly, let's see the answer to question 3 using the graph method. Now from graph method, the general form of a quadratic function, which is a graph, is y equal to ax squared plus bx plus c. That means the original question, which is x squared plus 2x minus 3 equal to 0, becomes y is equal to x squared plus 2x minus 3. That means the 0 has been changed to y. We do this because in our graph we are going to have two axes, the x-axis and the y-axis. Next, we are going to prepare a table of values for the relation y is equal to x squared plus 2x minus 3. We are going to use values of x from minus 4 to 2. Can you do this? Let's see if you can. Here is the table of values for the relation y is equal to x squared plus 2x minus 3. Here we have values of x from minus 4 to 2. That means minus 4, minus 3, minus 2, minus 1, 0, 1 and 2. So what we are going to do in this table of values, we are going to substitute the values for x into the terms of the equation for y. That means substituting the values for x into x squared into plus 2x. Of course, minus 3 is a constant term. Adding up this result, we are going to get our values for y. From the table, when x is minus 4, y is 5. When x is minus 3, y is 0. When x is minus 2, y is minus 3. When x is minus 1, y is minus 4. When x is 0, y is minus 3. When x is 1, y is 0. When x is 2, y is 5. Next, we are going to use a suitable scale to plot the graph of this quadratic function using the x and y coordinates from the table of values. If you plot the graph, this is what you will get as your result. Here is the graph of the relation y is equal to x squared plus 2x minus 3. From the graph, how can you tell the roots of the equation x squared plus 2x minus 3 is equal to 0? You can tell the roots of the equation from the point where the curve crosses the x-axis. Looking at your graph, you can see that the curve crosses the x-axis at point x is minus 3 and point x is 1. That means that the roots of the equation x squared plus 2x minus 3 is equal to 0 are x is equal to minus 3 or 1. I hope these solutions to question 3, they are all clear to you. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic quadratic equations, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.